Willett from Biotechnica. I'm here at ICEA in collaboration with my partner Sean Bailey, as well as Oron Catts and Zero of Tissue Culture and Art Project. We've developed a piece together called Teratological Prototypes, where we're utilizing tissue culture protocols to grow very small sculptures, critical sculptures that allow the audience to access, in a very real sense, what is the nature of this type of laboratory work, and to be able to think critically based on their own real lived embodied knowledge about how they feel about these technologies. Taken scans of our bodies, but we've also taken scans of teratoma sculptures, and then we've created models out of them and then cast them with polymers so that we can make the teratoma shapes. And then the shapes come in two halves, and originally we were going to fuse them together, but we really like the sort of Frankenstein look of the stitching, so we decided to sew them together instead of fusing them in a neater way. Now, in Australia we were growing mouse teratoma cells over the constructs, and I really appreciated that intellectually, but they're very delicate cells. They were, constantly subject to pressures that other cells would be more resilient to, and they were sort of dying on us on a fairly regular basis until we figured it out. So in this instance, we're actually using a different cell line. We're using L929, which is one of the very first cell lines ever established for scientific research.
What a teratoma is at the beginning?
That's okay. A teratoma is an endodermal sinus tumor or a dermatoid cyst. And what that means is that it's a tumor where the cells differentiate as they divide. So it's very similar to an embryo, except there is a flaw in the chromosomes that determines structure and rationality. So as the teratoma grows, it becomes irrational and grotesque. It's like teeth and hair and nails and nervous system, but it looks a little bit like a baby in a blender when it comes out. Up until the late 1960s, the Catholic Church was baptizing teratomas after they were taken out of the human body and burying them as virgin births. So we use the teratoma because it's actually a real locus of scientific research right now. Scientists are looking at the teratoma for possible solutions to human cloning goals, but also the teratoma is huge right now because the fundamentalist right in the United States is really postulating that the teratoma might be an ethical source of stem cells. That right now the teratoma doesn't have a postulated soul in the same sense that a fertilized egg would. So we deploy the teratoma because it's irrational and grotesque, and it meets all of our artful and art historical desires as artists for critically thinking about biotechnology, but also because it's very real. And so our project is all about that slippage back and forth between the fiction and the real. Good. Just skin cells, like this one. Yeah. Part of our thought with building this structure is that we wanted to examine the politic of accessibility to these technologies. In actuality, tissue culture can be very simple. I mean, certainly there's a learning curve, but for under $3,000, we built a fully functional laboratory, tissue culture laboratory, here on site, which means that it's far more accessible than we're led to believe it is in the public sphere.
Okay. My name is Oron Catts. I'm a researcher and an artist working with the Tissue Culture and Art Project. I'm also the artistic director of ZeroOne. So, my name is Oron Catts. I'm an artist and researcher. I'm working with the Tissue Culture and Art Project for the last 10 years, and I'm also the artistic director of ZeroOne. So, when we talk
a little bit about the project?
Yeah, this project is interesting. It's a collaboration between Leonardo and myself, the Tissue Culture and Art Project, and Sean Bailey and Jennifer Willett, Biotechnica. And what we're trying to do here is basically create two narratives that are meeting with one object or with one installation. Sean and Jennifer are interested in the teratoma. Leonardo and myself are much more interested in the whole notion of semi-living and the whole idea of what we're starting to refer to as the extended body, the notion of a new ecology of parts that is growing every day in the sense that there's more and more cells that are disassociated from the original bodies that are being used for different purposes. The interesting thing with this particular piece is that we are using mouse cells that were isolated from a mouse in 1948. So in a sense it's the oldest part of mouse in the history of the universe. It's 60-year-old. So And in a sense, and what I like also about this project, that the whole notion of trying to engineer a teratoma, which is a total absurd. Teratoma is a disorganized cancer of cells that's differentiated in different traits. What we're trying to do, we're trying to actually use tissue engineering techniques, which were developed to try and grow body spare parts, to try and, in a sense, reverse engineer or engineer a messy clump of cells.
Thank you.